Have you ever wondered why do the clothes dry when you hang them outside on a bright sunny day? The clothes dry automatically when you hang them outside on a bright sunny day because the water droplets present on the surface of these clothes convert into water vapor on absorbing sun's heat. And these water vapor then gets mixed with air molecules. So here we see that there is a change in state of water from water droplets, that is from liquid state to gaseous state or water vapor on absorbing heat. So this process of change in the state of matter like water from liquid to gas on absorbing heat is called evaporation. So evaporation is the process of conversion in the state of matter from liquid to gas, and this is the reason why the water droplets present on the surface of the clothes absorbs heat and convert into water vapor. Now evaporation is a surface phenomenon, and evaporation occurs at all temperatures, but it is more rapid at higher temperatures. Now you must have noticed that if you boil water in a bowl, the water slowly convert into steam or water vapor. So this process is known as boiling. So boiling is known as the rapid vaporization of a liquid at a particular temperature, and the temperature is usually 100 degrees Celsius. So 100 degrees Celsius is the boiling point of water. Now if you notice, in both evaporation and boiling there is a change in state of matter from liquid to gas on absorbing heat. But evaporation and boiling are not the same process. Evaporation occurs at all temperatures, but boiling takes place at a specific temperature, and the boiling point of water is 100 degrees Celsius. Also, evaporation is a surface phenomena, whereas boiling takes place throughout the entire liquid. So these are the differences between evaporation and boiling. We will now discuss about the factors that affects the rate of evaporation. You must have noticed that if you pour hot tea from a cup to a saucer, the tea cools down faster. This is because the surface area of saucer is more compared to that of the cup. So heat escapes rapidly from the saucer and the tea cools down faster. Similarly, more water molecules escapes if the surface area of the evaporating body is more. So the rate of evaporation is more if the surface area of the evaporating body is more. So in the previous slide, we saw that the rate of evaporation is more if the surface area of the evaporating body is more. This is because evaporation is a surface phenomena. So if the surface area is more, then more water molecules will escape from the surface of the evaporating body. Because of this, the rate of evaporation is more over the oceans than over the continents. The reason is that in oceans there are more water bodies compared to that in continents. So the rate of evaporation is more over the oceans than over the continents. So here we see that the surface area of the liquid plays an important role in evaporation. If the surface area of the liquid is more, then the rate of evaporation will be more. Have you ever used a hair dryer to dry your hair? If you have done that, then you must have noticed that if you use a hair dryer, then your soggy hair dries very quickly. But if you leave your hair to dry naturally, then it takes longer time. Now, why is this so? The reason is that due to higher temperature, the air mass expands and it becomes less dense. So, the moisture holding capacity of warm air rises and it absorbs more water molecules. Conversely, if the air temperature is less, then the air mass will contract and become more dense. So, the moisture holding capacity of cold air reduces and it absorbs less water molecules. So, here we see that the rate of evaporation is higher if the temperature is warmer. So, this is how temperature affects the rate of evaporation, and both are directly proportional. That is, higher is the temperature, higher is the rate of evaporation. Now, before we proceed with our lesson, let us try to answer this. The rate of evaporation dash with increase in temperature increases, decreases, or remains unchanged? Well, the correct answer is increases. The rate of evaporation increases with increase in temperature because both are directly proportional. In rainy season, the clothes hanging outside take a longer time to dry. Do you know why? The reason is that during monsoon or rainy season, the relative humidity is very high. That is, the air is already saturated with water vapor and it cannot absorb any more water molecules. So, the water molecules present on the surface of the clothes takes a longer time to evaporate or evaporates very slowly. On the other hand, if the air is dry, that is, if the relative humidity is low, then less water molecules are present in air. So, the air in this case can absorb more water molecules. So, here we find that relative humidity and the rate of evaporation are inversely related. If relative humidity is high, then the rate of evaporation will be low. Have you ever noticed that the wet clothes dry faster under a running fan than in normal conditions? Now, why is this the case? The reason is that if the wind speed is more, then more water molecules will escape from the surface of the liquid in the form of water vapor. While if the wind speed is less, then less water molecules will escape from the surface of the liquid in the form of water vapor. So, if the wind speed is more, then more will be the rate of evaporation. So, this is how wind speed affects the rate of evaporation, and on a windy day the rate of evaporation will be more. Now, apart from air temperature, surface area of the evaporating body, wind speed and relative humidity, there is yet another factor that affects the rate of evaporation, and that factor is air pressure or atmospheric pressure. The air prevailing in colder regions is dense, that is, it contains more air molecules. Now, the cold dense air exerts more air pressure compared to warm air. So atmospheric pressure is more in colder regions, whereas in warm regions the air is less dense as it contains less air molecules. So the atmospheric pressure is also less. Now if the atmospheric pressure is more, then it will exert more pressure on the surface of the water body. Now this increase in air pressure will cause difficulty for the water molecules to escape from the surface of the liquid. So if the air pressure is more, then the rate of evaporation will be less. Whereas in warmer regions where the air is less dense, their atmospheric pressure is also less, and hence the rate of evaporation will be more as water molecules will escape more rapidly. So here we find that air pressure and the rate of evaporation are inversely proportional. In fact, the rate of evaporation increases with decrease in air pressure. So these are the important factors that affect the rate of evaporation. The rate of evaporation is more if the surface area of the evaporating body is more. So the rate of evaporation will be more in this case because it has more surface area, and the rate of evaporation will be less because it has less surface area. Again, the rate of evaporation is directly proportional to air temperature. If the temperature is higher, then evaporation will be more. If the temperature is less, then evaporation will be less. The rate of evaporation is inversely proportional to relative humidity. If the air is humid, then it will absorb less water molecules in the form of water vapor. So evaporation will be less. Again, if the air is dry, then it will absorb more water molecules from the surface of the liquid, and the rate of evaporation will be more. Another factor that affects the rate of evaporation is wind speed. If the wind speed is higher, then the rate of evaporation will be higher. The last but not the least is atmospheric pressure. The rate of evaporation is inversely related to atmospheric pressure. If the atmospheric pressure is more, that is in colder regions, the rate of evaporation will be less, whereas if the atmospheric pressure is less, then the rate of evaporation will be more. So these are the vital factors that affects the rate of evaporation. So in today's lesson, we discuss the meaning of evaporation. Evaporation refers to a process where there is a change in state of matter from liquid to gas on absorbing heat. And then we understood the difference between evaporation and boiling. And we also discussed about the factors that affects the rate of evaporation, and these are the factors that affect the rate of evaporation. In our next video, we will discuss about condensation. Don't forget to subscribe to our channel and hit the bell icon. You can also register for free at DeltaStep.com or download the DeltaStep app to learn one-to-one with our amazing teachers, or to get access to our 5,000 amazing videos as per your school syllabus. Master each topic with our adaptive practice technology. Get million+ questions with step-by-step solutions and unlimited mock tests. Get all your doubt resolved instantly. Learn via games and win amazing prizes like PlayStations and iPads. So at DeltaStep, learning is not just fun and easy, but it's rewarding too. So register for free now.